Welcome to Space TV. Today, we're venturing into the heart of the cosmos to explore the life cycle of stars. Our journey begins within the dense and mysterious realms of giant molecular clouds. These are colossal cosmic entities, spanning light years across, and are composed mainly of hydrogen gas and dust. In these clouds, a fascinating process takes place. The gas and dust start to clump together under the influence of gravity. These clumps grow denser and denser, eventually forming what we call a stellar nursery. Picture it as a maternity ward, but for stars. Amidst this cosmic chaos, amidst this seemingly infinite darkness, new stars are born. But how does a star actually form within these nurseries? Well, as the clumps of gas and dust become denser, gravity's pull grows stronger. This pressure causes the core of these clumps to heat up, initiating the process of star formation. As the core continues to heat, it eventually reaches a point where hydrogen atoms begin to fuse together, forming helium and releasing energy in the process. This energy then pushes outwards, balancing the inward pull of gravity, and voila, a star begins to shine, illuminating the darkness around it. This process, from the initial clumping of gas and dust to the birth of a shining star, can take millions of years. It's a slow, yet relentless process that's always taking place in various corners of our vast universe. It's a cosmic dance choreographed by gravity and energy, a dance that's been going on for billions of years, and will continue for billions more. And that, dear viewer, is the miracle of stellar birth, the first step in the life cycle of stars. But remember, this is just the beginning. From here, the newborn star embarks on a journey that could last for billions of years, a journey filled with cosmic drama and unimaginable beauty. So stay tuned as we continue to explore the fascinating life cycle of stars in our upcoming scenes. From the chaos of the molecular clouds, a protostar begins to form. Imagine a grand cosmic ballet, where gravity is the choreographer, pulling together particles of gas and dust, drawing them into a swirling dance of creation. As these particles converge, they form a dense core, the heart of our nascent star. This core grows increasingly hotter and denser, a fiery crucible in the cold vastness of space. The pressure and heat at the core of this protostar trigger the process of nuclear fusion, where hydrogen atoms combine to form helium, releasing tremendous amounts of energy. This energy radiates outward, counterbalancing the inward pull of gravity, and setting the stage for the next phase of stellar evolution. Behind the veil of cosmic dust and gas, this protostar begins to shine, a beacon heralding the birth of a new star. So from a collapsing cloud of gas and dust, a star begins its life. Once the protostar phase ends, we enter the long-lasting main sequence stage. This is where the magic truly happens, and a star truly becomes a star. In this stage, stars like our sun are in the prime of their lives. They're like hard-working cosmic factories, carrying out a process called nuclear fusion. This is the process that powers a star and gives it its glow. Imagine our sun, a typical main sequence star. Deep in its core, hydrogen atoms are constantly colliding and combining to form helium. This process of fusion releases an incredible amount of energy, lighting up the star and making it shine brightly in the sky. This energy, this light and heat, is what makes life possible here on Earth. Now, this fusion process doesn't happen overnight. In fact, it continues for billions of years. For our sun, it's been happening for about 4.5 billion years, and it's expected to keep going for another 5 billion years. This is the longest phase in a star's life. In this stable phase, stars are like the adults of the cosmos. They've reached a sort of equilibrium. The inward pull of gravity is perfectly balanced by the outward push of energy from fusion. This balance keeps the star stable and allows it to shine steadily for billions of years. In this stable phase, stars continue to shine brightly, powered by the process of nuclear fusion. But what happens when a star ages and evolves? Well, let's delve into that captivating question. As a star burns through its nuclear fuel, it begins to change. These changes aren't random, though. They're dictated by the star's mass. You see, a star's mass is like its destiny. It determines how the star will live, change, and eventually die. A smaller star, like our sun, experiences a different journey compared to a star that's 10 times as massive. For smaller stars, they'll eventually exhaust their hydrogen fuel, swelling into a red giant. Larger stars, on the other hand, have a more dramatic evolution. They go through a series of expansions and contractions, becoming supergiants and then shedding their outer layers in a beautiful, violent display known as a supernova. So, a star's life isn't just about shining brightly, it's a tale of transformation, driven by the forces of the universe. As we've seen, the path a star takes is largely dependent on its mass. As a star exhausts its nuclear fuel, it undergoes dramatic changes. Now, our focus shifts to the next stage in stellar evolution, the transformation into red giants and supergiants. You see, stars are not eternal. They live off a delicate balance of gravity pulling inwards and nuclear fusion pushing outwards. But as stars burn through their hydrogen fuel, this balance begins to falter. The core contracts under gravity's relentless pull, becoming hotter and denser. This triggers the fusion of helium into heavier elements like carbon and oxygen, releasing an immense amount of energy. This energy pushes the outer layers of the star outward, causing it to swell to an enormous size. Our own sun, for instance, will expand to swallow the inner planets, possibly even reaching Earth. In this phase, the star, now a red giant or supergiant, shines with a brilliant red hue. But this grandeur comes with an expiration date. As the star continues to expend its nuclear fuel, the core grows denser, and the outer layers become more and more unstable. The star, once a stable beacon of light, is now a ticking time bomb. This phase marks the beginning of the end for the star. But fret not, for even in death, stars play a crucial role in the cosmos, setting the stage for the next act in the grand theater of stellar evolution, onward to the explosive finale, supernovae. In a final, grand spectacle, some stars meet their end in a supernova explosion. This is not just the dramatic end of a star's life, but a crucial moment in the cosmic life cycle. When a star has exhausted all its nuclear fuel, the pressure that keeps it stable disappears, and the star collapses under its own gravity. The collapse triggers a shock wave that ricochets outwards, causing the star to explode in a supernova. This cataclysmic event is so powerful that, for a brief moment, a single supernova can outshine an entire galaxy. But the supernova is not just an end, it's a new beginning. The explosion disperses the star's enriched remains across the cosmos, sowing the seeds for future generations of stars and planets. These remnants include heavy elements like gold, platinum, and uranium, which are forged in the extreme temperatures and pressures of the supernova. So every piece of gold jewelry you wear, every uranium-powered nuclear plant, owes its existence to these cosmic explosions. While the supernova marks the end of one star's journey, the elements it scatters across the universe lay the groundwork for new celestial bodies to form. In a sense, we all are children of the stars, made of stardust from countless supernovae that have occurred over billions of years. In their death throes, these stars create the building blocks for new stars and planets. But stellar death isn't the end of the story. Supernova explosions, while signaling the demise of a star, also give birth to new cosmic entities. These remnants, based on the mass of the original star, can form into either neutron stars or black holes. Neutron stars are the collapsed cores of massive stars, incredibly dense and packed with neutrons. Imagine a sugar cube's worth of material from a neutron star weighing as much as a mountain on Earth. That's how dense these stars are. On the other hand, if the progenitor star is massive enough, a black hole forms. Black holes are regions of space where gravity is so strong that nothing, not even light, can escape their pull. They are the ultimate cosmic recycling centers, taking in matter and energy and reshaping the fabric of the universe. Even in death, stars leave behind fascinating objects for us to marvel at. From birth to death, the life of a star is a journey of cosmic proportions. Our voyage began in the stellar nurseries, where stars are born from the gathering of gas and dust. This gave rise to protostars, the infant stage of a star's life, growing hotter and denser with time. These protostars mature into main sequence stars, like our very own sun, brilliantly shining through the process of nuclear fusion. We delved into the fascinating paths of stellar evolution, where the fate of a star is determined by its mass. Some stars swell into red giants or supergiants, engulfing nearby planets with their fiery expansion. The grand finale of massive stars is the spectacular supernova explosion, scattering enriched remains into the cosmos. What's left behind are either neutron stars or the enigmatic black holes, remnants of a star's fiery demise. And so concludes our journey through the life cycle of stars. Remember, every star in the night sky has its own unique story to tell. Thank you for watching Space TV and keep exploring the cosmos.